A very good day to the panelists. Allow me to introduce myself. My name is Chong Wei An, and the title of my study is Shear Strength Characteristics of Organic Sand Stabilized with Calcium-Based Fighting Agent. This study is under the supervision of Professor Mayat, Dr. Chan Chi Ming, and co-supervisors Wan Salina binti Sani. There will be 9 contents to be presented today, which are background of study, problem statement, objective, significance of study, scope of study, summary of literature review, methodology, expected result, and lastly, Gantt chart. First of all, I will give some introduction on the background of study. It is well known that a route network can underpin a developed country economy, transportation, and residents' living standard. However, according to a study conducted by Kamaruzzaman in 2019, there were 2.6 million hectares of land area in Malaysia is covered by peat soil, which are highly in organic matter content. This means that sometimes it cannot be avoided to build root network on the organic soil. Now, I will present on the problem statement of my study. Such organic soil is a problematic soil which has highly moisture content, low bearing capacity, low bearing shear strength, low shear strength, and high compressibility. It can pose geotechnical problems to foundation for constructions in terms of area of sampling, settlement, stabilization, in situ testing, and construction. According to a study conducted by Chang in 2016, cement stabilization are examined can generate 0.95 tons of carbon dioxide per each ton of cement production. Their new stabilizers should be considered as replacement for cement in order to reduce the emissions of carbon dioxide. The soil stabilization by using fiber is a soil reinforcement technique that gains attention. This is because fiber have tension resistance to resist stress before breaking. Therefore, this study is interested to investigate the effectiveness of fiber in stabilizing organic soils. For this study, the objectives of this research are as follows. Firstly, to formulate the optimal calcium-based fighting agent dosage for strength enhancement of organic sand. Secondly, to determine the shear strength characteristics such as cohesion and resistance between particles of the stabilized organic sand with few application considerations. The finding of this study enable readers to understand the knowledge and mechanisms of organic sand stabilization using fiber. The result of this study can be considered as a replacement cement by fiber in geotechnical application to reduce the amount of carbon emissions into the atmosphere. In addition, this study can be used as a guide to improve the foundation layer for construction and lower the settlement of organic sand in subgrade. Next, the scope of study is focused on the stabilization of organic sand by using fiber as a stabilizing agent. Secondly, the polymer of modified cementitious chemical stabilizing agent incorporates with fiber is provided by reinforced soil engineering Sdn Bharat. 3 main laboratory tests, which are direct shear tests, unconfined compression strength tests, and wind shear tests, are conducted in this study. Moving to the next content, which is the literature review. According to the Public Works Department of Malaysia, the plasticity index of sub-base layer cannot be exceed more than 6. Hence, the problematic soils is unsuitable to be used as fill material for root sub-base due to it has highly plasticity index value ranging from 10 to 61. The utilization of fiber as soil reinforcement material has been gave attention according to a study conducted by the researcher as stated in this page. The fiber has a low cost, lightweight, renewability, biodegradability, and high specific properties. Therefore, this study will take the chance to further study and investigate the effectiveness of fiber. Next is the presentation of the methodology of the study. The infographic shows the research process. The stage is started by identifying research problem and objectives, literature review, and methodology. After that, the materials used will be collected and preparation. And there are numerous laboratory tests will be conducted in this study, which are standard proton convection test, specific gravity test, upper limits, directional test, unconfined compressibility strength test, and Wenscher test. All the data will be analyzed and discussion after that. And finally, a conclusion and recommendation will be met. The aim of the laboratory test will be comply with the objectives that I stated in the previous slides. Next is the sample preparation. The table shows that the combination of mixture with different percentage, and this combination will be repeated by substituting different types of sand, which are mid sand, coarse sand, medium sand, and fine sand. 5 specimens per set were prepared for curing at different curing periods respectively. The curing periods were set to 0, 7, 14, 28, and 56 days. Experimental tests were conducted with the reach of each respective curing period. The next slide has listed all the laboratory testing that will be conducted in this study, which are shift analysis, standard proton convection test, specific gravity test, upper limits, directional test, unconfined compressibility strength test, and Wenscher test. During the PSM1, I have done UCS test and Wenscher test for 2 samples, which are organic sand and organic sand stabilized by fiber. From the UCS test, it can be clearly seen that the QU axial stress of the sand sample at curing period of 12 days is higher than the curing period at 0 day. The 2 samples are mixed with humic acid and also fiber. This shows that the strength will be increased if the curing period is increasing. Next is the Wenscher test. The organic soil specimen stabilized by fiber shows the increasing in the shear strength, while the unstabilized soil specimens remain constant along the 7 days of curing. The expected results of this study are as follows. After organic sand was stabilized by fiber, it will serve as highly performance root foundation layer. Secondly, it will be improved in shear strength for better stability of pavement. Thirdly, unconfined compressive strength will be improved for better stability of structures against loads. Finally, this section is the Gantt chart. The Gantt chart consists of 20 weeks. From the Gantt chart, we can see clearly that almost all the tasks is with the targeted and actual timeline. Therefore, that's the end of my presentation. Thank you for your time and have a good day. Bye bye.